If you recall, in our last lecture, we used sender private key. I want to display the length of this and also the length of our public key. So we'll change this to public key. Let's see how long these two are. We'll click on Send and OK, and down below we see the length being 64 and 128. Our sender private key data will come into JSON as a string. So this is a hex, so it's 64 bytes. Then our sender public key contains both X and Y, so it's 64 plus 64, which makes 128. Please keep this in mind, and I'm going to delete these lines for now. For example, let's access our wallet.go, and there should be a section where we generated our private key, public key, and displayed it as a str. We have our private key str here, and we're displaying it as a string using d bytes. Then for our public key, we're using %x and %x. We're connecting these two %x's, so that's why this results in 128 bytes worth of hex. When we're actually using this in our backend for Go, we can't process this because it's a string. We have to make this a private key struct. In order to make this conversion, we'll need to create a utils from now. For this, let's first go to our project. Then under utils, we have ECDSA.go. In here, we're going to work on our text string along with our private key, public key, and also signature. Let's first focus on our public key. We'll write func string to big int tuple, then string. We'll return big int and big int. We're going to write a function for this. For example, bx. And for now, let's not do error handling. We're going to write hex decode string. Then 64, meaning 64 bytes for bx. Following this will be by, and for this we'll bring the semicolon after 64. Next will be var bix, and we'll declare big int. We'll copy this line and rewrite this to biy. And for the program we're creating, we're not going to use this, but you could call bix set bytes. We changed the string to byte here, and what we created here, we can pass this in with bx. Then, for example, our x for public key will be stored in this big integer, and we can do the same for y. Y can also be stored in big integer and return a value. Here, we'll return bix and biy. I'm going to close the left part here, and for example, let's write func public key from string followed by a string. We'll receive the string for us. Then we'll want ECDSA public key returned. Regarding x and y, we'll write string to big int tuple and pass in s to this, followed by return and ECDSA public key, elliptic, p256, then x, then y. I'm going to pull up the public key document here that I previously introduced. Under our type public key, we specify elliptic curve, then create x and y big int. And that is exactly the information that we just wrote for our program and created a function for our public key struct. Then regarding our private key, we place the public key that we just created, and then comes big integer for private key. We don't have to write separate lines for private key, so it's much more straightforward. For this, we'll write func private key from string followed by string. And we also need our public key, then ECDSA. Then for our returning value, we want ECDSA private key. For our byte, we'll write hex decode string, and we'll pass in the string for our private key. Then we'll declare var bi big integer, followed by bi set bytes. We'll pass in bytes. Then return ECDSA private key. For this, we'll take the pointer for our public key and the big integer that we just created. Let's scroll up to our signature area. And we see here that we use %x and %x. We use this twice and it's 64 bytes. So let's write this here. Func signature from string followed by string. returning our pointer for signature. We'll use R and S, then string to big int tuple. We'll pass in signature from our string, and for what is returned, we'll place R and S's signatures. Right now we have two S's. For now, we'll rewrite this R and S to X and Y. With this, we've placed back values to R and S by creating signatures from string. And one other point here. With this string to big int tuple, we set 64 bytes. This is an assumption, so we do want to specify 64 bytes here. And if R and S here aren't 64 bytes, we'll save the length as 0. I would recommend writing this section like so. And let's work on another step. This one refers to our public key for our wallet.go. In this section, we're using %x, but let's add 064 here as well. Once we've done this, let's go back to our wallet server.go. First, we'll actually create our public key. We'll refer to our utils public key from string, which we just worked on, and we pass in t sender public key. Then the same process for our private key. We'll write utils private key from string and pass in t sender private key. We'll pass the string and convert our public key and pass that in. We also want to work on value, and regarding value, we won't refer to utils but run it here. So it's t value 32 and check if we can parse. If this isn't nil, then we'll want to print error, parse error in our log. Then we want to return error for our IO string. This will be followed by value 32. We'll convert our value with float 32. We want to display our results, so we'll say print public key followed by print for private key. We'll rewrite this to private key, and regarding our value, we want %.1f followed by our value, which is value 32. Let's rerun our program, and going on to our right side, let's click on Send, then OK. When we do, we're able to confirm that our struct for public key and private key are correctly stored and displayed. For our last line, even when float 32, we have a value displayed. This confirms that we were successfully able to convert our string into a data format that can be handled by Go. Let's delete this, and now let's write header add content type application JSON. We're going to use the data that we just used, and this time we want to send the transaction data information to our blockchain node side.